Okay, here we are back, and let's do this example. Now this problem is very similar to the previous one, except that I've added a voltage source in the middle instead of a resistor. So let's do the same thing. Let's take a look at there's my VG, that's what I've chosen as my ground point. And then I've defined this extraordinary node, and then I moved my resistor R3 up here so that I could define a VC right there and get rid of my R3 down here. And then, when I did this before, I defined outgoing currents like so, and I wrote my first equation, which was minus IS plus VA minus VG divided by R1 plus, what am I going to do about this one? I have two choices. I can either give it a variable name and eventually solve for it, or I can do something called a supernode. The reason that I can't easily do this problem is because I don't actually know the current that's going through this voltage source. So one way to do the supernode, I'm going to do in red, where I'll just define this whole node right here, including the voltage source as the node, and I will continue with my outgoing currents. In that case, I would say, okay, I had this one, yep, that's right here, this one, that's right there. Now this outgoing current plus VB minus VG divided by R2 plus VB minus VC divided by R3, and that is all equal to 0. Then I would need the equations. I'll just give myself a note here. VG is equal to 0 and VC is equal to Vs. That's all I need to do because I've taken care of all of the nodes in my problem. Another way to do this, let me erase that and make that not a supernode now, and let's do that in blue. So another way to do this problem is to define this current. And let's just call it something. I'm going to call that, I don't know, I3. Then, instead of doing my problem the way I did before, I will say minus S plus VA minus VG divided by R1. Those are these two currents. And then I'm going to say plus I3 is equal to 0. Then when I get over to this node, let's do a second equation. The second equation, I'm going to have to consider I3 coming in the same direction. The blue lines need to be going the same way. The red lines do not. The blue ones do. So then we would have what's coming in is minus I3. What's going out is plus VB minus VG divided by R2 and VB minus VC divided by R3. That whole thing is equal to 0. I also need to say VG is equal to 0 and VC is equal to Vs. And then I would solve these two equations together. So I have two ways of handling this thing that's called a supernode. The red way was to consider VA and VB jointly as a single large supernode and solve one equation. The second way is to solve two equations, and in that case I've defined a current going through my voltage source and coming out the other side. Now in both cases I need to add one more piece of information, and that is associated with this voltage source. I need to say that Vx is equal to 3I1. So somehow I need to have I1 in my equation. So another way I can put that is I can say Vx is 3I1, but I know what I1 is. It is 3 times VA minus VG divided by R1. Now I don't have I1 as a variable, but I do have Vx as a variable. So in this version, where I used it as a supernode, I would say that VB minus VA is equal to Vx, and I would say that Vx is equal to 3 times VA minus VG divided by R1. This actually gives me one equation, 2, and 3. Do I need 3 equations? What are my unknowns? My unknowns are VA, VB, VC, but VC is known here, VG is known there, but I still need Vx, so it's VA, VB, and Vx are what I would end up solving for. All right, what about over in this side? In this side, I need to be able to incorporate the information about Vx also. So I would include the information Vx is equal to VB minus VA, just VB minus VA, and that is equal to 3 times VA minus VG divided by R1. That's another equation. Sorry, I have 1, 2, this is going to be number 3, and number 4. So how many unknowns do I have? I have VA, I have I3, I have VB, I have Vx. So those are my 4 equations and my 4 unknowns.